Hey guys, in this video we're going to work our way through the Energy Pyramid Lab. So for those of you that might have been absent, this is your opportunity to see what we did in class. And for those of you that were here in class, this is your opportunity to get another look at what we did to hopefully help you understand more. Okay, so in this objective, or in this lab, we're taking a look at the energy pyramid. We're trying to understand how energy is passed from one level of the energy pyramid to the next, and how much energy is passed from one level to the next. So to begin this lab, we drew our picture of the energy pyramid. Okay, so I have a sample energy pyramid here, and you can see down here at the bottom that I have the got the producer level. Okay, so I've got my producers, and then that would be this level right here, and then my primary consumer level, and then my secondary consumer level, and then my tertiary consumer level. Remembering that ultimately the sun is the ultimate source of energy and drives this whole thing, provides energy for photosynthesis so that the producers down here at the bottom can live. Okay, and then we don't want to forget about our decomposers over here. They're responsible for breaking down the dead remains of plants and animals, and then returning those back to the soil so that those producers can use those things. Okay, so the first part of this lab, we simply drew a picture of an energy pyramid. If you were here in class, we did this in groups. If you weren't here, then this is what it would look like, okay? And including our four levels: producers, primary consumers, secondary consumers, and tertiary consumers. Okay, now, next, okay, this next part of this lab is we're looking at how energy begins at the producer level and is transferred up to the next level, and how much energy. So in this lab, we used beans to represent energy. So down here at the bottom, I've got beans, and according to your lab, it's 1,000 beans. Okay, it's 1,000 beans. So the first objective is to divide this group of 1,000 beans, 1,000 units of energy, into 10 groups. So 10 groups of 100. So in this next picture here, you'll see that I've got my 10 groups of 100. Okay. So this is what I begin with. There's my 10 groups down here of 100 beans each, okay, 1,000 total units of energy. And so what we're trying to do is see how energy is transferred and how much. So I go from this mass amount of energy at the bottom of the pyramid, okay, 1,000 units of energy, okay, and then we're going to see how much moves up. The pyramid, in the shape of a pyramid, as we've discussed before, really represents not necessarily the size of that particular level, but the amount of energy and the number of organisms in that level. So our producer level having the greatest amount of energy and the greatest number of organisms, okay, producers being plants and autotrophs. So whenever a group, okay, like primary consumers eat producers, okay, that energy goes from the producers to the primary consumers, as in our food chain, okay. So when you've got insects eating plants, eating grass, that energy goes from that grass to that grasshopper, for example. So we've got a certain amount of energy that is moved up to the next level, okay, because that energy goes from the producers to the primary consumers. Now, the question there is how much, okay. As we look at our next diagram, okay, I took one of these piles from down here and moved it up to our primary consumer. Just one. All the others, okay, stay behind. Now, if I do the math on this, one pile of 100 out of 10 piles of 100, so 100 out of 1,000, okay, as I move that up, that's only 10%. Only 10% gets moved up to the next level. So that means that the other 90%, okay, which is all of this down here, stays behind. And you say, okay, well, where does it go? Where does that 90% go? Okay, the 90% of that energy, the 90% of the energy is not transferred. It's just simply lost. Okay, we say it's lost. What do we mean by lost? Well, some of that energy is lost into the environment in the form of heat. So whenever you eat, you use some of that energy to maintain your body heat. You radiate that heat out into the environment. Okay. Other goes into the waste. Okay, 90%. Some of it goes into the waste product. So you guys know this. Okay, fact of life: when you eat, there's waste. Okay, very little of what you eat actually goes to your body functioning. a whole lot of it goes to waste and ultimately goes down the toilet. So only 10% of this, only that 10% gets moved up to the next level, which means that 90% over here, okay, down here, stays behind. It gets lost. It's a very inefficient process. Okay, so looking at our next screen, we're going to take that pile, that 10% that got moved up, that 10%, it was 100 beans that got moved up. So I started down here with at the bottom. So I started down here at the bottom with 1,000 beans. And then I moved up 100 beans. And what I've done in this is I've divided that 100 beans into 10 piles. So 10 piles of 100, 100 divided by 10. 100 divided into 10 piles would be 10. Okay, so each one of these piles right here, okay, is a pile of 10. So we've divided that up. So now what we're going to do in the next picture is we're going to move one of those piles of 10 up. So we took one of these piles of 10, was right here, right there in the giraffe head, and moved it up, okay, to the next level, because I'm only transferring 10%. So 10% again gets transferred up, where the other 90% down here gets left behind. It gets lost, okay, lost into the environment. And there's a rule that we really haven't, a law that we haven't talked about. It's called the law of conservation of energy, which means energy cannot be created nor destroyed. Okay, so the energy is not destroyed. It's not destroyed. Okay, but it gets lost. It goes into waste products. It goes into heat, which radiates into the environment. It just doesn't get moved up. Okay, so now, and you're probably starting to see the trend here. I'm going to take this one pile right here, this one pile, and I'm going to take 10% of that pile, and I'm going to move it up to the tertiary level. So if I take that pile, which is 10 beans, and divide a pile of 10 beans into groups of 10, it'll only be one in each group. So here in this picture, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay? So I've got my 10 individual beans there. Okay? So now, one of those beans, only 10%, is getting moved up, okay, to the tertiary consumer level. So in my next slide, you'll see that finally that one bean gets moved up. So down here, I started with 1,000 beans, but only 10% moved up, which equals right here 100. Oops, started to go a little too far right there. Okay, which means 100. But only, again, 10% goes up. So in this next level, I only have 10. But again, only 10% moves up. So here I only have 1. And then over here, 90% each time, 90% of the energy is lost. Okay, 90% each time. So each energy transfer, 90% gets left behind, the other 10 gets moved up. Okay, so thus we have our pyramid shape, because progressively less and less energy is moving up. Okay, 90% is wasted, 10% goes up. All right, so let's look at our lab sheet here and see how we can fill out this lab sheet together just a little bit. So producer level, it says beginning, right there, beginning number of beans. At the producer level, we start off with 1,000 beans. Okay, and then primary consumer, okay, or let's go across, I'm sorry, getting ahead of myself. Let's go to number of beans transferred to the next level. Well, we moved up 10%, so 10% of 1,000 is 100 beans. Okay, and right here it says, okay, what is this? Okay, what is the numerical? If I take A divided by B, what is that? That's 10. Okay, all right, that's 10. Okay, 10. What is that in percentage? That's 10%. Okay, energy not transferred. How much do we leave behind? 90%. Okay, so going back and looking at my diagram for primary consumers, how much did I start with at primary consumers? Well, remember that in the primary consumer, we only had 100 get moved up. Number of beans transferred to the next level. So primary consumer, we only start with 100. Okay, how many got transferred from there? Well, 10% of 100 is 10. Okay, number of beans transferred. How many transferred? if I take A divided by B, okay, right here, C, that was 10, which is 10%. How much is left behind? 90%. Okay, so now looking at the next one, secondary consumers. How many do we start off with our secondary consumer level? Okay, well remember only 10 beans got transferred, so we only started off with 10. Number of beans transferred from secondary consumers to tertiary consumers, that was 1. Okay, number of beans, A divided by B is still 10, which is 10%. And then how much is left behind? 90%. And then lastly, okay, tertiary consumers. Okay, if I'm looking at the tertiary consumer level, okay, how many beans did I start off with at the tertiary consumer? There's only 1 bean. Number of beans transferred to the next level, tertiary is on top, so none are transferred. Okay, this would also be 0. All right, 0, and then 0. Those are all zeros because we're not transferring any from tertiary. Tertiary would be our top level consumer. Okay, so hopefully this helped make sense. What we really want to take away from this is that whenever we transfer energy from one level, okay, of the energy pyramid to the next, 10% of that energy gets transferred, 90% of it essentially gets lost or left behind, if you will. Okay, and as we move up, we progressively get less and less energy till we get to the top, okay, of that energy pyramid. And you can also see how much energy is in the producer level compared to the energy in the tertiary consumer level. All right, so hopefully this helped you. Go back and watch this again, pause and rewind as you need to, and then come ask me if you have any questions.